Hello guys, and welcome to this second video tutorial of Maxsurf stability. So previously we saw how to create different load cases, add loads, add tanks and compartments, how to run different types of analysis like equilibrium or specified condition. So today we'll be seeing different types of analysis like hydrostatics, large angle stability, Kn values, and floodable length. So I'll start with upright hydrostatics. So the first thing that we have to do is go on analysis, set up our trim. In this case, I'll keep it to 0. Then you can either select a range of drafts or displacement. So I'm going to select a range of drafts. So my normal draft, which is 0.475, and my final draft will be 1 meter. Here you type in the draft increment or the number of drafts that you want, and it will calculate the increments for you. So I want 5 of them in total, so I'll type in 5 and click on OK. And now simply click on Start Analysis, and it will calculate my hydrostatics for that range of drafts. So now if I go on my results window, now I can see my hydrostatics, but for every single draft condition. So if I now go on my graph window, here you can see everything plotted in the graph. So this can be very useful information because it will provide you with your displacement, mass sectional area of image shapes, wetted area, water plane area, LCB, LCF, KB, KMT, KML, your immersion, your moment to trim by 1 centimeter. All of it is here for the range of displacement that you entered, so you can know all of these values for your boat at any displacement. That's quite handy. So let's move on to the next one. So we go on large angle stability. Okay, we go on analysis. First we have to set up the heel. So I'll say I want it to go from -30 up to 180 degrees in steps of 10. Or you can, for example, say from -30 to 0 in steps of 20, in steps of 5. Then you can say from 0, that you can say then to 30 in steps of 1. You can choose these steps increment like that. You can also choose the direction. So in this case, I want it to start to heel towards starboard, from port to starboard. So that's all selected. Now we can click on Start Analysis. This error is simply coming up because I have the criteria turned on, otherwise it wouldn't have come up. So now if I go on my results, now I can see my my GZ, which is the length of my righting lever given in meters, from -30 all the way to 180 degrees. And not only my GZ, also my area under the curve, my displacement, my drafts, my waterline length, my prismatic coefficient, block coefficient, LCB, LCF. So these are also very powerful information. If I go now on my graph window, I can now see my maximum GZ, which is 0.79 meters at 48.2 degrees. So this is my zero line, so you can see here. So from minus 30 is negative, then when it gets to 0 up to 48.2, it reaches its maximum. Then from 48 degrees and ahead, it keeps decreasing until it reaches roughly 110, 115 degrees. I'll be probably able to see if I drag it. So it reaches 0 at 111.9, so 112 degrees. And then our lever becomes negative, so we will go into an angle of lull and our boat would capsize. So again, your maximum GZ and the curve under the area, your maximum and minimum values will be given by the relevant regulations towards stability. So you may be wondering, what's this downfloating point? So basically, if you go on your profile view, select your key points window, you can enter the location of a point. So in that case, it's this point on my gunwale. So obviously, if my boat heels over 31 degrees, it would come in touch with the surface. There will be water on the deck. So that's how you create downfloating points. So you can see it here reflected on the graph. So sometimes regulations will give you the angles in radians. I believe you can change that in your units. Yeah, here you can see it. So it says GZ area angular measurement units. So you can choose either degrees or radians. So let's move on to the next one. So the next one will be KN values. All KN values are, they allow you to calculate your GZ curves at any displacement or draft. I'm going to go on analysis. I'm going to select a displacement range. I'm going to say from 6 tons up to 20 tons. I want 5 displacements. That's fine. And I'll click on Start Analysis. Okay, so it has calculated that. If I now go on my current result window, now I can see my KN for this range of degrees, which you can set in your hill. So now when you go on the graph window, now you can see your KN curves. So if you, for instance, know that your displacement is 14 tons, and then you know that your heeling is 0 degrees, then you know that your KN will be 0. However, if you know that, for instance, your displacement is 12 and you're healing at an angle of 30 degrees, then your Kn will be 0.95 roughly. Sorry, 0.931. Displace it here at the bottom. So with this value, you could calculate your GZ. So you can take any of these displacements and then calculate your Kn for each healing angle and build up your GZ curve from it. So it's quite useful for captains and masters, who then can check their stability on board without using Maxsurf. So the next one we'll see will be floodable length. So I'll go my profile window. I'll go on analysis. You can give a trim or a displacement range. I'll keep it as 3 tons. One displacement only. You can give it more. You can give it a final displacement of, for instance, 10, 7 increments. So it will calculate it will go from 3 to 10 in increments of 1 ton and give you that final result. So given that, you just go and start analysis, and what Maxsurf will do, it will calculate the maximum length of your hull that can be flooded without causing the boat to sink. So if I now go on my results, you can see my floodable length values in here. So now if I go on my graph window, this curve represents my margin line. So that means that any compartment sinking going above this line will cause sinkage. So this purple line is my only single compartment, which is the hull itself. So obviously if it gets flooded, it will sink. You can see it's well above this line. However, if I create bulkhead, so if we go on this window, then hit Control N. In my case, I have to close my bulkheads, the previous ones. So if I hit now Control N, it will start a no bulkhead. And now if I type Control A, I can add more. So I'll add maybe 7. So I'll name them 1, 2, 3, 4, 5, 6, and 7. And then the location of the first one will be 1.5 meters. The second one will be 3 meters. The third will be 4.5. The fourth will be 6. I'll leave it like this for now, and I will run the analysis again. Okay, so it's all done now. If I go back on my graph window, now I can see my floodable length here. So if we go on and display data format, you'll probably have one compartment by default, so it will look like this. So what this means is that right here at the bottom you can see your overall length. So mine goes from 0 to 11.5. So at 1.5 position is my first bulkhead, 3 meters position, my second 4.5, 6 and 11.5. So that means if the compartment between the bulkhead at 6 meters and 11.5 meters gets flooded, it will go above my margin line, causing the boat to sink. If any of the other compartments sinks, since they are below the margin line, they wouldn't cause the boat to sink. Now if I go on display data format, and I make my maximum number of compartments 2, this displays when two adjacent compartments get flooded, both of them. So if compartment 1 and 2 get flooded, the line is still below the margin line, so it wouldn't cause a sinkage. However, if compartments 2 and 3 get flooded, they will go above the margin line. Same here. So if I now go back to my bulkheads and create a few more, so we can say one at 7.5, another one at 9, and another one at 10. Recalculate that. So as you can see here, if the two forward compartments get flooded, they will be still well below my margin line, so nothing would happen. Probably could even afford having these 3 compartments flooding without the boat sinking. However, in this part, these 2 compartments would cause the boat to sink, so you would probably need a third compartment here at the 2.5 position, or 3 position, 3 meters, and then another one here probably. So if you add a couple here and here, it should be below your margin line. Again, your normally, according to regulations, depending on the type of boat and the code, there will be a safety factor, which will be a percentage of this margin line below. So it's all depending on regulations. So now we can set a bit of damage stability. So if I now go my damage case window, I can click on File and say no damage cases. I'll call it damage case 1. There we go. So I just clicked on Control A, typed Control A in order to create my damage case. So now I have my my 3 previous compartments I created in the previous tutorial. So now in my damage case window, I can say I'll create 3 different damage cases. I'll create 4. So in damage case 1, my aft will be flooded. In damage case 2, only my mid. In damage case 3, only my forward. And in damage case 4, maybe my mid and forward. And now if I go on equilibrium, for example, I can select my damage case here. So I can say damage case 1, hit play, and then it will simulate what happens in case of the flooding of that compartment. If I now say damage case 2, damage case 3, which will be my forward, and damage case 4. The trim value exceeded 75 degrees, so it's not looking any good, is it? So that's what would happen if the mid and forward compartment get flooded. Definitely sinking. Okay, so you can also use these damage cases in order to calculate your latch angle stability, also your upper hydrostatics, maybe your Kane values. So yeah, just a quick recap. We've gone through upright hydrostatics, latch angle stability, equilibrium, specified conditions, Kn values, limiting kg, and floodable length. So I may do another tutorial covering some other functions from Maxsurf stability, but I think we're on track for now. So thank you very much for watching, and I'll see you in the next one.